But I don't want to go too much into detail on chemical bonds just yet, but I want to give a basic introduction. There will be more details given in video 4a on polar, covalent, and ionic bonds. So let's just split it up into three basic bond types. There's ionic, covalent, and metallic, which we're just not going to talk about. Most everything, this chalkboard, you, me, hair, tables, are really covalently bound together. So they're molecules, they're bound together. Ionic bonds are a little less common. Where would you find these? So salt is a common example. Salt is an ionic compound. When we use the term compound, usually instead of molecule in this case. Even the chalk that I wrote that with is a calcium compound of sorts, right? Calcium carbonate. So it's ions held together, fairly brittle. Calcium tends to be a little less soluble than things like the table salt or even baking soda. So this is a sodium bicarbonate. All right, so similar to the chalk, except it's sodium instead of calcium. Even the eggshell, a lot like the bones, is made out of ionic compounds, mostly calcium carbonate, much like the chalk. So these ionic compounds, as we know, are held together when you have a positive ion, and that could be a molecule or just a single atom, but it has a positive charge, and another one with a negative charge, and that's it. They're attracted to each other because of those opposite charges. It's a little bit like, and this is just an analogy, so it's a little bit like these magnets. These are a couple of refrigerator magnets, and if you try to put them together this way, they don't want to stick together because they're the same charge. So if we had two positive ions, they would repel each other just like these magnets are. But if we turn them around, then they stick together nicely. And that's a little bit like an ionic bond, right? Those opposites attract. And these can then form large lattice works, like in this image up here, where you see the green and the purple balls all held together. That would be like a salt crystal. So in that case, there's not just a single molecule. It can just keep adding parts as far as it wants to go. Very often, these will break up in water, right? So they are electrolytes, break up into individual ions that float around in solution. And like I was getting at before, the sodium and the potassium tend to break up a little easier. Calcium tends to stay as that ionic compound, which is how we get our bones, right? Because they're a calcium mineral, a salt of sorts that is also held together by those proteins. All right, well, how about covalent bonds then? How do those work? They're different than the ionic bonds. They're not different charges attracted to each other. It's formed by sharing a pair of electrons. A lot of times we show those covalent bonds, like this diagram up here, as just lines between different chemical symbols. So the line between the carbons is just showing that there's a covalent bond there. But what is that? Well, if we think of these as the nuclei of two different atoms, so just the nucleus, the protons and the neutrons, we know electrons circle around those. And that's going to be the case for both of these. And if we get them close enough together, then they might start sharing those electrons between them. And that holds them together in a covalent bond. So instead of showing it like that, we might just show that a covalent bond between two carbon atoms. Now that's a little bit like these two keys held together on this key ring, right? That would be a little bit like a covalent bond. They're pretty well stuck together, just like these guys are. Most molecules are pretty stable. Ionic bonds are stable as well, for most of them as long as you keep them away from water. So covalent bonds are stable, but we can do a chemical reaction, right? We can add some energy, break that bond, and then have the two separate atoms again. So quick overview of covalent and ionic bonds with a few examples. Again, most things are covalently bound together, and that's where we'll spend most of our time. But ionic compounds and the ions they formed are really important when it comes to a lot of biological processes. So we don't want to leave them aside. That's it for now. More details to come later on.